60 feet. That's the length of a city bus. And it belonged to an octopus. That single measurement, published in the journal Science in April 2026, stopped paleontologists mid-sentence because nothing in the fossil record had prepared anyone for a soft-bodied animal that size. But the creature itself isn't even the strangest part. In the next few minutes, you'll see how this giant was hiding in plain sight, already catalogued, already stored in museum collections, and what that means for every other gap in the prehistoric record. On April 23, 2026, a paper landed in Science with a claim that rewrote the Cretaceous ocean. A giant octopus, not a squid, not a shark. An octopus once stalked prehistoric seas roughly 100 million years ago. Its estimated length, 60 feet, or about 18 to 19 meters. The animal is now formally named Octopuses hagarthi. The largest giant squid ever recorded falls about 20 feet short of that. N. hagarthi may have been one of the largest invertebrates to have ever existed on Earth. The evidence came from 27 fossilized jaws, octopus beaks recovered from Japan and Canada's Vancouver Island. Paleontologist Yasuhiro Eba of Hokkaido University and his co-authors compared those ancient beaks to the jaws of modern octopuses to estimate body size. The animals those jaws belonged to ranged from 23 to 62 feet in length. Here's why no one saw this coming. The Cretaceous ocean had famous monsters, mosasaurs, plesiosaurs, enormous sharks. Soft-bodied cephalopods like octopuses barely registered in the fossil record. No hard skeleton, no teeth, no scales, just muscle and intelligence dissolving into sediment over millions of years. So researchers had a problem. How do you study an animal that leaves almost nothing behind? The answer, it turned out, was already sitting in museum drawers. The team used a technique called digital fossil mining, systematically re-examining existing museum collections using computational comparison methods. 15 jaws had already been recovered from Japan and Vancouver Island. But when the team applied this approach to Japanese collections, they identified 12 additional jaws that had been catalogued and never fully analyzed. 27 jaws. One pattern. One giant that had been waiting, unrecognized, for someone to look properly. The jaws didn't just reveal size. They revealed behavior. The beaks from the largest individuals showed significant wear, scratches across the surface, chipped edges, rounded tips. That kind of damage doesn't come from catching soft prey. It comes from repeatedly crushing things, shells, bones, armored marine animals. Whatever N. hagarthi was eating, it was going after hard targets, consistently, over millions of years. The Cretaceous seafloor was rich with ammonites, large crustaceans, and shelled creatures. This animal appears to have made a living dismantling them. Then came the reclassification, and this is the part that surprised even the researchers themselves. For years, fossils like these had been loosely categorized as relatives of the vampire squid, that strange deep-sea animal sitting somewhere between octopus and squid on the evolutionary tree. The new analysis overturns that entirely. N. hagarthi and its relatives are now classified as ancient members of the finned octopus lineage, the group that includes today's Dumbo octopuses, named for the ear-like fins they use to glide through deep water. That quiet, drifting creature you might see in a nature documentary. Its evolutionary ancestors were crushing bones on the Cretaceous seafloor. The lineage didn't disappear. It shrank, retreated to the deep, and survived while the giants were gone. Paleontology has a soft body problem. Animals without hard skeletons leave almost nothing behind. And that gap has historically led researchers to underestimate how large and ecologically significant these animals actually were. Digital fossil mining offers a way around that. The technique doesn't require a new expedition or a dramatic discovery. It requires going back to what's already been collected and looking at it with better tools. 12 of the 27 jaws in this study had been sitting in Japanese collections, catalogued and unexamined. They were already there. The giant octopus was already there. The record isn't fixed. There are almost certainly more specimens like these in existing collections around the world, waiting for the right method to extract what they actually contain. The question the April 2026 paper leaves open isn't just what lived in the ancient ocean. It's what else is already in a drawer somewhere, mislabeled, under-examined and waiting. Octopuses hagarthi didn't need a dramatic discovery moment. No remote expedition, no accidental find. It emerged from 27 fossilized jaws, a comparison method borrowed from modern biology and a technique applied to museum collections that already existed. The 60-foot apex predator was hiding in plain sight. And if one giant can stay hidden until 2026, the question the field now has to sit with is harder. How many others are still waiting? Subscribe to factstormhub for more stories like this. And if you want to go deeper, the full article, sources, and recommended reading are all at factstormhub.com.